All right, we want to start practicing simplifying some trig expressions. Now you should have a sheet of 46 fundamental trig identities. If you don't have that, look around this page. You should find a link where you can print off the PDF. We should have a few of them already memorized, and we should be working towards memorizing a few more. I want to bring up the reciprocal identities for secant, cosecant, and cotangent. That secant is a reciprocal of cosine, cosecant is a reciprocal of sine, and cotangent is a reciprocal of tangent. We also have the Pythagorean identities. Remember, that comes from the Pythagorean theorem, and we saw that sine squared plus cosine squared is equal to 1. But there are 3 different Pythagorean identities. We could take this basic one and divide every term by cosine, and we would have tangent squared plus 1 is equal to secant squared. Or we could take that fundamental Pythagorean identity and divide everything by sine, and we would have 1 plus cotangent squared is equal to cosecant squared. These and a few more are going to be pretty fundamental when you're doing your homework, and definitely in this video. Before we get to the simplifying part, I want to remind us about factoring and look at factoring some trig expressions. If we're going to factor sine squared of x minus cosine squared of x, a good way to go about these, if it starts to look pretty confusing, is to think of something simpler. That with sine squared minus cosine squared, that's a lot like a squared minus b squared. And we remember how to factor that as the difference of 2 squares into a plus b and a minus b. Now, when we apply that over to the trig expression of sine squared minus cosine squared, the pattern is still the same. We have the difference of 2 squares, so one of my factors is going to be the square root of each term, so sine of x, cosine of x, added together. And the next factor is going to be its conjugate, sine of x minus cosine of x. Here's one that looks a little messy, cosecant squared of theta minus 2 cosecant of theta plus 1. If we rewrite this as something simpler, like x squared minus 2x plus 1, thinking back to our Algebra 2 days, we would just factor this as x, and then we factor the 1 into 1 and 1, and we're trying to make negative 2x, so both of them would have to be minus. Since we have 2 factors that are the same, this is x minus 1 squared. Now, applying that to the trig expression, the idea is still the same. We can follow this pattern, and instead of x's, what we have is cosecants. So this is the same as cosecant of theta minus 1, the quantity squared. One thing I want to emphasize one more time is that maybe when we talk about trig, we say things like cosecant minus 1 squared. Make sure that when you're writing these down, for cosecant, you don't just write cosecant. You have to include the variable with it. Cosecant is the operation. The theta is the variable. So make sure you write cosecant of theta minus 1. Let's do one more. We have 4 cosine squared of alpha plus cosine of alpha minus 3. So first, we think of something a little bit easier, like 4x squared plus x minus 3. And how would we factor that? Well, we'd break it into 4x and x. Since I need factors of 3, they're going to make a 1. That would be 3 and 1, because on the outside we'll have 4x. On the inside we'll have 3x. So plus 4x minus 3x would be that 1x that's in the middle. Now we can take that and apply it to our trig expression, because everything that was an x is now going to be a cosine of alpha. So this will factor into 4 cosine of alpha minus 3 times cosine of alpha plus 1. When we think about simplifying the quantity a minus b squared, we would think that what we have to do is multiply that out. Taking a minus b times a minus b, and remember foiling and all of that. Real quickly, it should simplify down to a squared minus 2ab plus b squared. When we're trying to simplify the trig expression of sine beta minus cosine beta, the quantity squared, we do start off in those algebraic terms where we are going to take the sine minus cosine and multiply it by itself. And when we do that, we get that similar product that will have sine squared and then double the product of those two, so 2 times sine and cosine, and then plus cosine squared. Algebraically, we would have stopped there, but since we're dealing with a trig expression, we have other trig identities that can help us to simplify things. For instance, we know that sine squared plus cosine squared is equal to 1, and so we can take those two terms out and replace it with 1 and have 1 minus 2 sine beta cosine beta. Now with what we've got so far, this is where we're going to stop. If we're going to simplify the algebraic expression a over 1 plus c over a, what we would do first, since we're adding two fractions together, is to get a common denominator. Our common denominator is going to be 1 plus c times a, which means this a would have to be multiplied by another a, and this c would have to be multiplied by the 1 plus c. When we multiply out the numerator, we'll have a squared plus, distributing the c gives me c plus c squared. We can multiply out the denominator as a plus ac, and that's about all we could do algebraically. Now that we have a similar trig expression, sine t over 1 plus cosine t over sine t, it looks a little messier, but the idea is still the same. That the very first thing we want to do, since we're adding fractions together, is to get a common denominator. Our common denominator would have 1 plus cosine t as one factor, and another factor would be sine of t. Which means that when we add these together, this sine of t would have to be multiplied by another sine of t, and cosine of t, it's in the second fraction, would have to be multiplied by 1 plus cosine of t. Now we would do the algebra of multiplying this out. Sine times sine is sine squared, and we would distribute the cosine. Cosine times 1 is cosine of t, and cosine times cosine is cosine squared of t. Now I'm not going to multiply this out because I know where it's going. What we have to do now that it's a trig expression is to see if we have any other trig identities that we can use. And we look and quickly we see that we have this sine squared plus cosine squared again. So I'm going to replace that with a 1. And we'll have 1 plus cosine of t over 1 plus cosine of t times sine. And since we have two factors, one in the numerator and one in the denominator, that are the same, they're going to cancel just like they do in any other fraction. So what I'm left with in the numerator is 1 and just sine in the denominator. We also know that 1 over sine, that's one of them reciprocal identities, and the reciprocal of sine is cosecant. When you're simplifying a trig expression, the best that you can do is to get it simplified down to one single trig function. So not having a fraction, but just having the trig function is definitely more simplified. Cosecant is more simplified than 1 over sine. Algebraically, if we were going to simplify a over c plus c over a, again, this is two fractions, so we would get a common denominator having factors of c and a. So this a would get multiplied by another a, and the c, that's the numerator of the second fraction, will get multiplied by another c. Now when we multiply this all out, we have a squared plus c squared over ac, and we're done. If we're going to simplify cotangent plus tangent, the first thing that I would do is turn it into sines and cosines. And cotangent is going to be cosine over sine. and tangent is the reciprocal of that, which is sine over cosine. Now we have two fractions that we want to add together, so we need a common denominator. Our common denominator is going to have a sine and a cosine as its two factors. Then going back to the numerators, the cosine that's in the first fraction would have to be multiplied by the denominator of the second one, that second cosine. And the sine, the numerator of the second fraction, would be multiplied by the denominator of the first one, the other sine. When we multiply these out, we'll have cosine times cosine is cosine squared, and sine times sine is sine squared, all over sine times cosine. We know about that identity for sine squared plus cosine squared, and order doesn't matter when we're adding, so cosine squared plus sine squared is 1. So 1 over sine cosine. And of course we can break that up into 1 over sine times 1 over cosine. The reciprocal identities for sine and cosine, the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. So there's our simplified trig expression. Alright, I got one more. 1 over cosecant minus 1 over cosecant plus 1. We're subtracting two fractions, so we're going to need a common denominator. My common denominator is going to have cosecant minus 1 as one factor, and the other denominator, cosecant plus 1, as the other factor. Going back to the numerators, the one that's in the first fraction has to get multiplied by the denominator of the second fraction, cosecant plus 1, and the one that's in the second fraction has to get multiplied by the denominator of the first fraction, cosecant minus 1. When we multiply that all out, just distributing the ones, we'll have cosecant minus or plus 1 minus cosecant minus negative 1, so plus 1. When we FOIL the denominator, we see that we have two conjugates, so that product is going to be the difference of two squares, which is cosecant squared minus 1. Doing a little bit of simplifying, in the numerator we see that we have cosecant minus cosecant, so those two are going to cancel, which means in the numerator we just left with 1 plus 1, which is 2. In the denominator we have cosecant squared minus 1. And anytime you got something squared and a 1 in there, you should be thinking about a Pythagorean identity. Now we don't have a Pythagorean identity that says cosecant squared minus 1. Instead we have number 11 on your sheet that says 1 plus cotangent squared is equal to cosecant squared. Well, if we were to just subtract 1 from both sides, then we do have this cosecant squared minus 1. So we know that cosecant squared minus 1 is equal to cotangent squared. And of course now we got cotangent in the denominator. The reciprocal of cotangent is going to be tangent. So tangent squared of theta. And here's our simplified expression. One thing to point out about simplifying these trig identities is when you look at the problem that we started with, that expression of 1 over cosecant minus 1 over cosecant plus 1, there's no way that you could tell that was going to be 2 tangent squared of theta. My point is, it takes work. So make sure that when you're practicing in your homework and stuff, you show some steps. Keep things neat, keep things organized, and that's what's going to help you through simplifying these trig expressions the most.